So today we're going to be talking about measurements first. Measurements are what we use to calculate things. When you have to find out the quality or the quantity of a chemical substance that you're using and that you're working with, you do measurements on it, and then you use those measurements to do calculations which give you the results that you were looking for. Some measurements that we regularly take in your IGCSE syllabus are time, temperature, mass, and volume. Now, the SI unit, now what's an SI unit? The SI unit is the standardized unit system that we all use around the world. This is done because you need a single set of units that you're using, which means that people from around the world, they can look at your data and they can understand what you mean, and they can get an easier way to work with it. The SI unit of time is the second, which is represented with a small s, and the apparatus that you can use to measure time is, say for example, a stopwatch. The SI unit of temperature is the Kelvin, which is represented by a large K. The apparatus for temperature is a thermometer. For mass, it is the kilogram, which is represented by a K and a G together, both small, and its apparatus are the beam balance and the weighing scale. For volume, which is basically space taken up by any object, the SI unit is the meter cube, which is represented by a small m raised to the power of 3. The apparatus for measuring volume are usually beakers or measuring cylinders, or basically objects which can contain stuff in them. Next, we move on to methods of separation. So now, why do we need separation or purification? You need that because sometimes you've got substances which are made up of multiple types of materials. Say supposing you've got salt and water, and maybe you want just the salt and you don't need the water anymore. How do you go about doing that? How do you go about changing the composition of this substance of salt water to just get your salt, which is your desired material, right? So now we're going to look at some methods of doing so. First up, we've got filtration. So filtration is used when undissolved solid particles are separated from a liquid. So what that means is, say supposing you've got chunks of chocolate chips in milk, right? So when you've got that and you want just your chocolate chips back, what can you do? You're gonna run it through a funnel, right? So essentially you're gonna filter that out. So this employs the same mechanism. And so if you look at the diagram here, you've got a couple of things. You've got a beaker, you've got a filter funnel, which is basically this Y-shaped thing you see here, and you've got a conical flask, which is where your filtrate is going to collect. So now what happens is, when you've got the setup in this Y-shaped object, which is your filter funnel, you've got some filter paper, which is basically a sort of paper with very fine holes in between them, which allows the particles of a certain size to pass through. So water molecules are very tiny, hence they can pass through easily. So over here, if you see the suspension of chalk in water, the chalk particles are larger and hence they can't pass through the filter paper, which is and they're larger and they're not dissolved in it, which means that the particles have not been easily spread out into the solution, and hence you can still see them, you can still feel them. And this is why when you pour the solution into the filter funnel, the water is going to pass through the filter paper and drip down the filter funnel into this conical flask, which is where it will collect. Now this water is known as the filtrate, which is the solution which has passed through the filter paper. Now the chalk particles are going to get held back by the filter paper and stay on in that certain space in the filter funnel. Now that is known as the residue. That's filtration for you. Moving on to centrifugation. Centrifugation is essentially using centrifugal force to separate undissolved solid particles from a liquid. Technically, it is to obtain the same result as filtration, but it employs a certain different method. Now, if you imagine a bottle, right, which is open-ended, and it's got some liquid in it, and then if you swing it round and round, you will notice that the fluid inside will not drop out, because if you do it fast enough, the force that is being applied, the momentum that the liquid has going away from you, will not allow it to drip down and come out of the mouth of the bottle. Right. So centrifugation uses the same principle. You've got a centrifuge. That's a machine which spins the mixtures at very, very high speeds. Now, when you're spinning the mixture at very high speeds, particles in that solution which are heavy are going to get deposited at the bottom of the tube, of the test tube, right? And it's going to get deposited at the bottom. And if there are multiple types of particles in there, they're going to be divided as according to their weight. So say supposing you've got a tube which has a solution which has got water, okay, and it's got chalk particles, and it's also got a number of rocks, right? So now the rocks are obviously going to be the heaviest particles over there, followed by the chalk particles, followed by your solvent, which is the water. Now in a centrifuge, when it's being spun around, the rock particles are going to be the heaviest, and hence they're going to fall back right at the back of the tube and get collected there as the base layer. The chalk particles, which are slightly less heavier, are going to be deposited on top of those rocks, and finally the solvent is going to be above that. So these particles, having been deposited at the bottom of the liquid, can then be separated using decanting, which is basically the process of pouring the solvent out from a beaker or a flask without letting any particles inside in the solution fall out as well with it. So that's centrifugation for you. Next we move on to distillation and fractional distillation. Distillation, the idea of it, is used when you want to separate a soluble liquid or a soluble solid from another liquid. If you look at distillation here on the left, you've got this apparatus here which shows a round bottom flask, which is what you see over here on the left, that's being heated with this burner, and then you've got this tube sort of thing over here which you see. Now what that is a Liebig condenser. It's named after a very famous scientist who did a lot of very important chemical experiments in his time. So what this does is it condenses the vapors rising from here after being turned into the gaseous form in this round bottom flask on the left here. So once that happens, the liquid drips down into this conical flask over here. Now what that means is, over here where you've got the solution, you can control at what temperature you're keeping this round bottom flask. So say supposing you've got some salt water, right? Now salt is dissolvable, it's soluble in water, right? What that means is you can't decant it, or you can't use filtration to get out the salt. So what you've got to do is you've got to set your thermometer to say 100 degrees, which is the boiling point of water, correct? You've got to get your burner up to that temperature and maintain it there. So what that's going to do is it's going to boil the water over here. The water is going to rise up, as vapor, leaving the salt behind, the salt particles behind. It's going to rise up and travel through the round bottom flask and into this condenser. Now the condenser has cool water coming in and moving around this tube, which has the water vapor going in. So that's going to cool down that water vapor and convert it and condense it into liquid, which is water basically. And once that happens, it's just going to drip down as normal pure water without any of the salt in it, as this distillate over here, leaving behind the salt over here. And now you've successfully separated your solute and your solvent. Fractional distillation is the practice of distillation using two soluble liquids. So now say supposing you've got a solution which is made up of two soluble liquids, one whose boiling point is at 80 degrees Celsius, and the other one which has a boiling point of 96 degrees Celsius. So now if you want to separate that, what you can do is you can set up the same apparatus here, except with a fractioning column over here with glass beads, which keeps your cooling to a more efficient level. And you can set the temperature to 80 degrees Celsius, which is the boiling point of your first liquid, right? So once you've set it at that, and you heat this solution over here, only that particular liquid is going to get to its boiling point and be converted to vapors, right? And what that's going to do is it's going to make that particular liquid, say supposing liquid 1, and it's going to make it rise up into this column, and then it's going to go right into this condenser here. And like we said before, this condenser is going to cool it down and convert it back to liquid form and get it down into this flask over here as the distillate. The second liquid, whose boiling point was 96 degrees Celsius, will have remained a liquid right through, because it's simply not reached the energy level required to be converted into a vapor, and hence you will have separated your two liquids. Next, we move on to crystallization. Now, the idea of crystallization is pretty simple. You've got a soluble solid and you've got to separate it from a liquid. So what you do is you heat the mixture and you make the liquid in the mixture evaporate and disappear as vapors. So what you have left is just your solid solute, which is what you wanted in the first place. Lastly, we come to chromatography. Chromatography is the idea of separating two or more miscible liquids. The entire process consists of two phases. In paper chromatography, the stationary phase is the paper. So as you can see here, the process goes in the flow from left to right. So right in the beginning, you've got your chromatography paper on which you make a line, a pencil line, and on that line, in the center of it, you make a spot of your mixture, which contains the two or three or more miscible liquids, which you want to separate. And then this paper is hung over a beaker like so into the beaker which contains the solvent. You then dip the paper till that line that you've drawn into the solvent, so which means that the level of the solvent should be at that line. The mobile phase is that particular solvent. What this means is that solvent is going to be mobile, it's going to be moving, and this phase is going to carry the different liquids in your mixture along with it up the chromatography paper. Each component of the mixture travels a different length according to its chemical composition. Based on the number of spots, you can figure out how many components are in that particular mixture. and you can identify that substance using the retention factor, which has the symbol RF. Now this factor is, the value of this factor is calculated by the distance moved by the substance upon the distance moved by the solvent front. So over here, if you see towards the right, if you see dB over here on the left where I'm pointing, you can see that the center of this spot has a distance of dB from the pencil line that we had drawn before. So this distance, this perpendicular distance that it has traveled, is going to be equal to a very specific solvent or particular component, which can be identified once we've measured that distance and checked with our data. Now sometimes the components are colorless, which means that the different mixtures don't have any color and the components cannot be identified with the naked eye. What is done then is that the chromatography paper itself is treated with certain agents. They're called locating agents, which make it easier for you to identify the different spots and figure out the distance that they've traveled. The paper is heated after the chromatography process is done, and that makes the component colored, and hence you can then identify and work with it with ease. Now every substance has a specific boiling and melting point, and using these points you can identify them. But sometimes these substances can contain impurities, and according to these impurities, the boiling and melting points are changed as there are different types of particles in one material. Hence, to check the purity of substances, we check their melting and boiling points. A general idea of the kind of effect that impurities have on substances is that it causes melting points and boiling points to happen over a range of temperatures. So say supposing you have impure water, it's going to not be boiled at exactly 100 degrees Celsius, or it's not going to melt at exactly 0 degrees Celsius. Instead, it's going to be boiling over a range of temperatures. So for example, between 98 and 102, hypothetically. And it might melt from between 1 degree to 2 degrees instead of 0 degrees. So that's how impurities can affect certain substances.